Okay, in this tutorial we're going to be looking at inverse graphs and relations. Okay, so our inverses can be found by switching our x and y coordinates. Okay, so if we've just got a set of ordered pairs, okay, we just switch our x and y coordinates around. For equations, we switch the x and y, okay, and rearrange for y. Okay, and the important thing to remember is that the domain and range will also switch since we're switching our x and y's. And for the inverse to be a function, the original must be a one-to-one function. That is, it must pass a vertical and horizontal line test. Okay, and really the idea too with these, okay, is that we're doing a reflection in the line y equals x. So the inverse is a reflection in the line y equals x. Okay, so we'll have a look at a work example. This section is not too long, so hopefully we'll get to it pretty quickly. Okay, so we're needing to sketch a graph of y equals x cubed minus 2x minus 3, and on the same set of axes sketch a graph of the inverse. So we need to start off here by finding a bit of information. Okay, so our y-intercept, okay, is going to be when x equals 0, so that's going to be simply at y equals 3. Okay, our x-intercept, okay, well we need to factorise our equation. And, oh, sorry, I made that a bit harder than what it needs to be. It's x squared minus 2x minus 3. Okay, so we factorise and we get x take 3 and x plus 1 equaling 0. Therefore x equals 3 or x equals negative 1 for our x-intercept. Okay, we need to work out our turning point. Okay, we could complete the square to find it, but the easier way is we know that our turning point has an x coordinate that's halfway between our x-intercept, so we know our turning point is going to be at x equals 1. So turning point at x equals 1, okay, and y will equal 1 squared minus 2 times 1 minus 3, okay, which is minus 4. So our turning point is at 1 minus 4. Okay, and basically we've got everything we need to be able to sketch this now. So if we draw a set of axes, okay, we know that we need the point negative 1, 0, and we need the point 3, 0, and we need the point 1 and minus 4, and we also need minus 3 on here. Okay, so now we can draw our graph. So now our turning point's here. Okay, so it's going to be something like that. Okay, so 1. Now we can think our graph is going to be reflected in the line y equals x. Okay, so just putting that on there to give you an idea, but we're not actually going to do it that way. Okay, because what we're going to do, okay, is remember that we've got to be switching our x and y coordinates. So at our 0, negative 3, we're actually going to be at negative 3, 0. At the point 1, 4, negative 4, we're going to be at negative 4, 1. So we know we're going to be in here as well. Okay. We also know point 3, 0 is now 0, 3. Okay, and the point minus 1, 0 is now 0, minus 1. Okay, and our graph, our new graph will be something like this. Okay. and then we've got our inverse. So inverse is in the red. Okay. The next part is actually talking about the domain and range. Okay, so our domain and range for our original, I'll do it in blue. Okay, well, our domain is all real numbers because it's a quadratic. Okay, now range is from -4 to infinity, which means when we switch them, okay, our domain of our inverse, okay, is going to be from -4 to infinity, okay, and our range, okay, will be from all real numbers. Okay, now the only other bit that we need to think about, okay, is how we make our inverse function, well, our inverse relation, an inverse function. Okay, you can see here that our inverse, okay, is not a function because it won't pass the vertical line test. We can draw a line, and there's plenty of places where we'll cross the graph more than once. Okay, although our original equation was a function, okay, because it would pass the vertical line test. Okay, but in order, as we said earlier, in order for our inverse to actually be a function, so for our inverse to pass the vertical line test, then our original will need to pass the vertical and the horizontal line test. As you can see here, it doesn't. Okay, so word example 10 is talking about the equation, okay, and what sort of restriction we could do to the domain in order to ensure that the inverse is a function. And essentially, we basically just split the quadratic in half. That would be the maximal domain that we can go. So if we looked here, we could split it in half down here. Okay. And if you use just the left or just the right, we would end up with a one-to-one function. Okay, so we need to make the domain either from -infinity to 1, okay, or from 1 to infinity. Okay, and that'll give us the largest possible domain in which we're still a one-to-one function. Of course, you could just use a narrow sliver. You could just say from 0 to 1, that would just be this part here, clearly passes the vertical and horizontal line test. But these are our maximal domains. So that's everything for this section. So hopefully that's enough to get you through with the questions you need to do.